Okay, for this exercise, we want to limit the weights to a maximum of 20% for each stock. So this is a common constraint put on portfolios that you can't let one stock dominate the portfolio, meaning given the variance covariance matrix, and if a stock has fundamentally a low covariance with other stocks and it has a high return, then the mean variance optimization may put 80% of the portfolio in that stock. So it's common to add a constraint such that no stock can be more than 20% of your portfolio. And I think I'm going to put a constraint here that you can't short. So it's going to be each weight has to be between 0 and 20%. So to do that, all we have to do is look at the GitHub README, right? And we can kind of Control F and look for constraint, CONSTR. There we go, adding constraints and different objectives and so forth. So this gives us, fundamentally what we need, weight bounds. So we can go ahead and do that. I have it in here. So we can set the weight bounds from 0, so no shorting, to 20%, and calculate the portfolio weight. So here we have the portfolio weights, and notice we don't have more than 20% in any given stock. We can do look at it, and we can see, okay, well, we have about 20% in these 3 stocks, and then less in the others. And we can get the Sharpe ratio. The second part of the exercise is to state the optimal portfolio in terms of amount of shares to be bought. So the idea here is, if you just have the weights, then you have to take, you still have to calculate, well, how many shares roughly is this, right? So 10% of your portfolio is, let's say if it's $100,000, roughly 10,000. So then you have to say, okay, 10,000 divided by the price per share of Apple, and that gives me roughly the number of Apple shares I should buy. But this can go ahead and do that for us. So we can run this here using this discrete allocation with our portfolio size. So this is our portfolio size here, which I guess I have 100,000. What are we supposed to use? Do I say 100? Yep, I say 100,000. So that's good. So what this means is buy 83 shares of Apple, 1,313 shares of GE, and so forth. And then we have, because we're not buying fractional shares, we have some left over, $3.82. Now, for the bonus here, it says, as you narrow your weight constraint, what happens to the portfolio's, basically what happens to its Sharpe ratio. And as a general principle, so the nice thing that now that we have this notebook, we can sort of test the theory behind it. And in general, as you constrain a system more, the optimal solution is worse and worse. So as I free the system, the solution becomes better and better. As I constrain the system, it becomes worse and worse. And we can test this. So we can let's just look at our Sharpe ratio, 10.61. So if I lower this constraint to 0.1, we're going to get a lower Sharpe ratio. So we should see lower than 10.61. And there you go, 6.13. Conversely, as we raise this, right, so it's 6 here, it was at 20%, it was a Sharpe ratio of about 10. So let's see, at 30% it should be above 10, right? And there we go, above is 12. So that's the theory. We can answer this just purely on the theory of it, but it's nice to have this to go in and confirm that our intuition is correct.